Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 49 of Physics 5054. Uh, Today we are going to discuss in greater detail the concept, working principle and usage of thermocouple. Ladies and gentlemen, in the last lecture, we discussed different types of thermometers, in which yesterday we discussed the liquid in glass thermometer. The second type of thermometer is the thermocouple. Now, usually teachers are discussing the usage of a device at the end of the topic, but I am discussing it at the beginning to generate your interest. Because if you understand that where the thermocouples are used, then you will be curious to learn this topic. So let us discuss first the usage of the thermocouples are used to measure number one, very high or very low temperatures, and that can be from minus 200 degrees Celsius to 1500 degrees Celsius. This is very low temperature, and this is very high temperature, 1500 degrees Celsius. So the first usage of this device is that it is used for very high or very low temperature. The second usage is the temperature of small devices. For example, if there are small devices inside a washing machine, inside a computer, the processor, the RAM, the ROM, the CD-ROM, the DVD-ROM, and many more other devices. If we want to find the temperature, then we can use thermocouple. No thermometer is used inside those devices. The third usage of this device, which is known as thermocouple, is the temperature. It is used to measure the temperature at a distance. Ladies and gentlemen, this is such a responsive and sensitive device that if you are burning a telematches and you are keeping it at a distance, still this thermocouple will detect that temperature and it will give you the temperature at a distance. So if there are temperatures which are very far, not that much far away that it is here in another city, but in the vicinity from far away, it can record the temperature. This is another property. Rapidly changing temperature due to low thermal capacity, because in this we will discuss in a moment that we are using pure copper wire. So the thermal capacity of copper wire and iron is very low. It means that it can absorb very low heat and temperature. So quickly it is giving you the response, and that is rapidly changing temperature due to low thermal capacity is another property of this thermocouple. Okay, let us now see the construction. In the construction, we have to keep in mind that there are two different metals. That is very important. In this, the red wire is copper wire and the two other wires are iron wires. This is important. where the two wires ends are meeting, they are called junctions. There are two junctions of these two wires. One is called hot junction and the other one is called cold junction. Why they are calling hot junction? Because it is immersed, or it is uh, placed at a location of which we want to find the temperature, unknown temperature. And this is called cold junction because it might be placed in a cold place. Usually it is placed in an ice, in the ice cubes of pure melting ice, and that is at 0 degrees Celsius. There must be a differences of temperature there in the two metal wires. Ladies and gentlemen, because this is hot and this is cold, so heat flow from hot body to cold body inside this wire. So when the heat is flowing, so these two iron wires are connected to millivoltmeter. It is also called millimeter. Millivoltmeter, and millivoltmeter is used to detect a small potential difference. So this end will be at one potential and this end will be at another potential due to the differences of the temperatures. So a small detection will be shown in the galvanometer when we place these two junctions at different temperature. One will be fixed and the other we will place that where or of which device we want to find the temperature. Ladies and gentlemen, keep in mind one thing, that if both the junctions are in hot water, no flow of heat will take place, and as a result the millivoltmeter will not show any deflection. Similarly, if both the junctions are in the cold ice, melting ice, again we will not observe any temperature differences, and as a result we will not uh, see any temperature, any deflection in the millivoltmeter. One thing more, that many devices are also using galvanometer. Galvanometer is a device for the detection of current, while voltmeter is a device for detection of potential difference or voltage. So when there is a potential difference, there will be a flow of current. So for the flow of current, we will use galvanometer, or if we want to find the potential difference between these two junctions, we will use millivoltmeter. Both the devices are used inside this type of material. So keep these things in mind, that if galvanometer in some literature you will find, and in few of the literature you will find millivoltmeter. So both are the same, either potential difference or potential or current will be observed. So this is the general construction, and now the working principle. We will discuss this in a moment, that is thermopile. This is thermopile. We will discuss that in a moment, but first let us discuss the working principle of this thermocouple. If you want to take proper work from the thermocouple, you have to put the cold junction in a pure melting ice, as in this case that is 0 degrees Celsius. And the second, put the hot junction in the uh, uh, place whose temperature is need to be found. So here we are putting one junction in hot water. There must be a temperature, otherwise this device will not work properly. Now the third thing, this is the first step and this is the third. The galvanometer will show a small current if it is galvanometer when there is a temperature difference between the two junctions. Instead of galvanometer, we can use millivolt meter, which will detect the potential difference between the two junctions. And that is what I told you. Wait a minute, ladies and gentlemen. There is a question. And the question is that this thermocouple is detecting the current and it is not detecting the temperature. How we will, because this device is used to find the temperature, so it is giving us current or voltage. How we will find the temperature? One thing you must have to keep in mind, and I mean it, the thermocouple does not measure the temperature. Very interesting. We are talking about the temperature, but measures the temperature difference between the two metals. There is a temperature difference between the two metals. If somebody is telling you that thermocouple is used to measure the temperature, it is wrong. It is measuring the temperature difference between the two metal, and as a result, in the next topic we will see that how can we measure the temperature then. If it is not measure the temperature, and we are learning this topic in the context of temperature, if this is the case, then how we can measure the temperature? From this device, there are two methods for measuring the temperature. Every thermocouple is having uh, a predefined chart, and there are values of voltage and the corresponding temperature. Every thermocouple is coming with a predefined chart according to the metal used. It is not necessary that always you should use the copper wire or the iron wires. So there is a chart coming with the thermocouple. Whatever current or voltage you are noting in this device, you have to see the chart and the corresponding value of temperature. If this milliampere is the value of this, then this will be the temperature. This is one method. Remember that if we are changing, this is at one temperature and this is at another temperature, then the galvanometer, first if it is at the same temperature, it will show you zero deflection. But if we are putting hot water inside it, so it will show you another temperature. If more hot water are, it is not necessary that the place whose temperature is measured, then it will give you more deflection due to the current flow or the potential difference between the two junctions. So here you have to note that this is 15, and here it will be written that the current is 15 millivolt, then this will be the temperature of that device. That is one thing you can measure the temperature. I told you this is not giving you the temperature. In the second case, there is a predefined calibrated galvanometer or voltmeter is coming. When you are attaching these two wires with this device, then you have to be careful that it is coming built-in mechanism, and directly they are showing you the temperature of that device or of that area in digital form or in analog form as well. It is calibrated like this, that if this is the voltage 15, that the temperature will be 37 degrees Celsius. If that is the 16, this device is showing, so it means that will be 38 and so on. So there is predefined calibration of that as well. Remember, ladies and gentlemen, that this device, again, I am telling you, it's not measuring the temperature, but it is measuring the difference is in the temperature in the form of current, which is the flow of electron, are the difference of potential. That will be at high potential and this will be at low potential, and current always flows from high potential to the low potential. When there is a current flow, then we will use to detect that small current, small change in current by galvanometer. And if we want to find the potential difference between these two junctions, then we will use millivolt meter inside that case. So there are two methods from the chart and from the uh, predefined calibrated galvanometer or voltmeter connecting to the metal. Now, epsilon is directly proportional to delta theta. Epsilon means EMF. EMF means potential difference. Is directly proportional to change in the temperature. What does it mean? It means that if there is more potential difference, there will be more change in the temperature, unknown temperature. For example, this is fixed at 0. You are putting a bit hot tea inside this cup and you want to find the temperature of that tea. But you are finding that temperature to be low, it is not takeable. We cannot take that tea because it is very cold. So you are giving more temperature to that and then you are putting it inside this cup. So it means that now the potential will be different from the previous one. So if the potential first was 3 millivolt and now it is 5 millivolt. So at 3 millivolt you will get one temperature and at the 5 millivolt you will get another temperature. So that is why change in potential difference is directly proportional to delta theta. Delta means small change, not large change. Small change. Theta means the temperature of that body which we are going to find. Okay, ladies and gentlemen, directly proportional means one is increased, the second one will also increase. If there is a change in the temperature, larger one, then there will be greater potential difference. And I wrote you this is a Greek word epsilon, and that is used for potential difference or electromotive force, EMF. is the power of the battery in cases of DC. In case of AC current, AC voltage, we are calling it voltage, but in case of DC, we are calling it EMF. Both are the same in one context. Delta theta means change in temperature. Now, ladies and gentlemen, if we want to use this device and preferring it over the other devices we studied in the previous lectures, then what are the advantages of that over the clinical and the laboratory thermometers? They cannot, the range of those thermometers are not that much high. It is from minus 200 degrees Celsius to 1500 degrees Celsius, very high range of 1700 degrees Celsius, which is not the capability of the clinical thermometer and the laboratory thermometer. Ladies and gentlemen, for measuring a very high temperature, we have to use the many wires in series, many junction in series. Uh, it must be connected for a large number of wires to produce large current or potential. Then those things which are connected in series are called thermopile. Why they are used for measurement of high temperature. So if you want to find a high temperature, then it means that you are using thermopile. Thermopiles are devices which are used to uh, measure the large temperature, and many of the wires such junctions can be connected in series, not in parallel. So what are the series connection and what are the parallel? When we go to the electricity chapter, we will discuss that, but for the time being, only remember that for high temperature measurement, you have to use what? You have to use this thermopile. Okay, the second advantage is it can be used to measure localized temperature. If we want to find the temperature is at a specific point of the wire, then we are using that thermometer, and we can find the temperature at a specific point of the wire or device. Here what is the temperature, and here what is the temperature, and here what is the temperature. Then we can use only thermocouple. This is not the capability of other devices. Now, because of the small mass and low thermal capacity, it cannot absorb more heat. And because metals are good conductor of heat, because of these three properties, rapid change can be observed. On one side you give heat, and the other side you will get a very rapid response from this thermocouple. Why? Because the mass is small. When the mass is small, what happened? Low thermal capacity. What does it mean? It means that it cannot absorb. When you are giving heat to this wood, it will absorb the heat, it will absorb the heat, it will absorb the heat, and when it fills up, then it will start showing you the temperature increase. For that particular purpose, this is having low thermal capacity, so they are giving rapid changes. Because the output is an electrical signal, so can be connected to electrical appliances for rapid change in temperature. For example, in ACs, there is a temperature change in the room when we are putting the AC on 24. So when the temperature of the room reaches 24 degrees Celsius, then automatically it will break the circuit and stop. When it come back down again, it is starting. For automation purpose, we are using the thermocouple, because inside the AC cabinet and the temperature, there is difference. This is inside and this is outside. Similarly, in washing machines, if we are use automatic stoppage after a time interval, then we can use, because it is using electrical signal. So we are saying that if electrical signal are reaching to this particular point, then stop the thing. Ladies and gentlemen, one small work example is remaining. We are also doing it. So I have to erase a part of the whiteboard. Wait for a second. Okay, ladies and gentlemen, let us discuss the work example 8.6, which is on page number 125 of your book. And it is saying it is in a certain thermocouple thermometer an EMF of 4 plus 4.0 millivolt uh, was obtained with one junction in melting ice and the other in the boiling water. Melting ice and boiling water. Uh, at one standard atmospheric pressure. When the hot junction was taken out of the boiling water and placed in a boiling propane, that is taken out and then immersed inside the boiling propane, uh, the EMF register was minus 1.50 millivolt. Find the temperature of the boiling propane on the thermocouple Celsius scale. So the solution is, ladies and gentlemen, we wrote a formula that potential difference is equal to change in temperature. In the first case, we are having 4 millivolt and the temperature difference is 100 minus 0 degree Celsius. In the second case, the galvanometer, the voltmeter is giving us minus 1.50 millivolt and the temperature difference is theta minus 0, and while theta is the temperature of boiling propane. So because we want to find the theta, so theta minus 0 divided by 100 minus 0 is equal to minus 1.50 divided by 4.0. Dividing this by this and both sides uh, respectively. So here we will write theta a divide by 100, and that is minus 1.50 divide by 40. So now we have to do what? We have to write theta is equal to minus 1.50 divided by 4.0 multiplied by 100, and that is minus 37.5 degree Celsius is the answer. So this is a practical usage of this topic, and we got the temperature of unknown. So in this way you can use the thermocouple. Ladies and gentlemen, that's it for today. Tomorrow we will start the problems relating to the temperature and heat. That is very important. Don't miss. Thank you for watching. Allah Hafiz.